Um, the title card was a lie. Vincent is also joining us today, who you may know from his algorithm whiteboard videos or
Other stuff.
other stuff. Yeah, I'm thinking about the things you're working on now and trying not to like say anything spoilery.
Nah,
So,
so,
Vincent, you may also know.
yeah, no, so next week there's going to be an announcement. It's going to be fun.
Yeah, keep your eyes peeled for that.
Yeah, next week.
Uh, today, okay, there we go. So now YouTube has caught up for us. So YouTube audience, there's this much delay between us and you, whatever the video is at right now. And Twitch is also good. Hi everyone, good morning. It's exciting times here on the West Coast, and well, Seattle is not as bad as San Francisco. We do have quite a bit of smoke, and there's a smoke warning in effect today. So if I sound a little raspy, that's why. Vincent, you were saying before the call started that you had gotten interested in this topic. ... Do you want to?
Yeah, so like in general, I have this notion in my mind that it's been happening in my mind for like a year now. Like this whole notion of grid search is not enough. Like if you do AutoML, you're gonna need more than that. And recently, I've started noticing that the idea of model checklists has been gaining traction. This paper seems to be about an NLP model checklist, which is interesting. I've also been contributing a little bit to the Dion checklist. That's more for ethics in general. Can recommend.
How is that spelled?
Dion, D-E-O-N. It's a really cool project. It's a clear YAML. So it's like a YAML file that you can add to your GitHub page. And then the idea is that the GitHub page can then say, not every human has ticked every box off yet. That's the one. There's also, for everything to check off, they have a very clear example of something that went wrong on a specific theme elsewhere with links. So it's a very informative source. I like that way of thinking, mainly because you can probably do more good with a good checklist than with a number from a grid search result. So I'm interested in what people have thought of in NLP for that.
Always the case with, one sec, let me move my mic. As is always the case with this particular type of live stream, we have not read the paper previously. This is our first time going through it. Oh, stream is disconnected. Give it just a second. Network instability.
Oh dear.
So, as is always the case with this particular type of live stream, we have not previously read the paper. So this will be our first time through it. And I can tell that I'm cutting in and out with the audio. And I hope this is being saved and people see it when the stream reconnects. Give us a second. Some network instability on my side. Okay, excellent. And we're back up. Very frustrating. So we've not read the paper previously. This particular paper is from ACL 2020, which was held this July, online. And this paper actually received Best Paper. So this is an award that's given, recommendations are made by the reviewers, and I believe the full programming committee weighs in on the selection for honorable mentions and Best Paper. So this was the Best Paper from ACL.
This is more than just a good grade. This is sort of considered to be one of the papers you should read this year in that sense.
Yes, absolutely.
Okay. Oh, lucky me. I'm reading it.
Yeah. And it was also, when we did the poll a tiny bit ago, the second choice for folks of the thing that they wanted to read. So that's why we are reading a second.
Nice.
So the paper is Beyond Accuracy, Behavioral Testing of NLP Models with Checklist, and it is by Marco Tulio Ribeiro, I'm guessing, Tongshuang Wu, Carlos Guestrin, and Samir Singh. And so his affiliation here is listed as University of Washington. I'm pretty sure he's at Apple as well. He might have a dual affiliation. I'm pretty sure he's like head of AI at Apple. And then Microsoft Research, they have a number of offices. Marco might be from up here in the Seattle area. The University of Washington is in the Seattle area. And then UC Irvine is in California. So all on the West Coast. Do you want to kick off by reading the abstract?
Yes, please. Okay, so abstract. Although measuring held-out accuracy has been the primary approach to evaluate generalization, it often overestimates the performance of NLP models, any machine learning model, while the alternative approaches for evaluating models either focus on individual tasks or on specific behaviors. Inspired by principles of behavioral testing and software engineering, we introduced Checklist. Is there a special reason why it's a different font, or?
I think they're just using that as the name. Right. A lot of time, algorithm names will be given.
Just as a highlight, basically. Mm-hmm. Okay. But they introduced Checklist, a task-agnostic methodology for testing NLP models. Checklist includes a matrix of general linguistic capabilities and test types that facilitate comprehensive test ideation, as well as a software tool to generate a large and diverse number of test cases quickly. We illustrate the utility of Checklist with tests for 3 tasks: identifying critical failures in both commercial and state-of-the-art models. In a user's We illustrate.
I followed you down that path.
Yeah, right. So we illustrate the utility of Checklist with tests for 3 tasks, identifying critical failures in both commercial and state-of-the-art models. I thought 3 things were going to get listed, but it's got to come. In a user study, a team responsible for a commercial sentiment analysis model found new and actionable bugs in an extensively tested model. In another user study, NLP practitioners with Checklist created twice as many tests and found almost 3 times as many bugs as users without it. Okay. Stuff that will find you bugs is always a good thing.
Absolutely. Vincent, are you familiar with behavioral testing? Can you talk about it a little bit?
So I'm not so to some extent, maybe. Like in industry, I have had clients before where what we did was like actually have a human being behind a laptop and checking their behavior on the website and then asking for the assumptions later. I don't know if that is the definition of behavioral testing, but
yeah, I also don't know. It sounds like UX testing, where you have someone come in and try a program, and you have someone like standing next to them being like, oh, they clicked on that. Well, so one of the things I did for money in grad school was do UX testing for Microsoft.
Well, so I actually have one funny anecdote about this. So there's this big Dutch website. Let's not name which one. But the idea was they had like a new way of trying to find the right ads and products for you on that website. So they had someone come in. They said, could you please log in to this website? And we would love to just ask you questions about the ads that you see. And the ads were all about taking a holiday in Suriname, which is the country in South America. The guy said, well, I have no idea. Like, I don't know. Like, I've never been there. In fact, I'm not even interested in it. And then after like an hour of asking, it turns out that his wife is from there. But he didn't recognize that maybe that was, like, if his wife also uses his account, it didn't occur to him that that was something that might be causing this. That's why you're doing this behavioral thing, because our users are not aware that might be a thing, even though to us engineers, it's super obvious. Super useful, but you're only going to get that by testing it in the field with actual humans.
Definitely. And also, just doing a quick Google, it looks like a lot of this stuff is psychology.
Yeah, that makes sense. Like,
maybe they'll talk about it more in the body of the paper.
The main point they're trying to make here is, I think, they have an actual human being there. It's not a test statistic, which I can sympathize with.
Mm-hmm. Yeah. Amir on YouTube says, waving Vincent, Rachel, this paper has been on my reading list, so it's nice to have it now with you. Yes. It was also on my reading list. So, yeah, let's hop in. If I were to like summarize this in one sentence, it is, this is a way of testing NLP models besides just looking at a specific test metric that you're optimizing for. And held out is for like cross-validation. Introduction. One of our primary goals in training NLP models is generalization. Since testing in the wild is expensive and does not allow for fast iterations. The standard paradigm for evaluation is using train, validation, test splits to estimate the accuracy of the model. And this is, you split your data into 3 parts. One part, the biggest part usually, is used to train your model. And then as you're training your model, you use the validation data to be like, is this, reasonable, and check for overfitting. And then the final test set you only use once to validate the model at the very end and be like, oh, okay, yes, this is actually good, or oh, whoopsie, we didn't actually generalize well. Including the use of leaderboards to track progress on a task. And a lot of the papers that we've read in the reading group have had, leaderboards, and they're like, here's the metric we're using, blue or accuracy or whatever, and our model does better than these models, and therefore we're top of the leaderboard now.
We claim bragging rights.
And there's a lot of discussion in the NLP community about whether that's actually a good way to do research, or whether it just sort of really privileges labs that have a lot of money to run bigger and bigger models. We'll table that, but
yeah, let's not get into that. I think it's an interesting discussion there, but let's table it for now. Yeah,
definitely. Well, performance on held out data is a useful indicator. Held out data sets are often not comprehensive and contain the same biases as the training data, so they're not a good sample of what people are going to be doing in the world, such that real world performance may be overestimated. Further, by summarizing the performance as a single aggregate statistic, it becomes difficult to figure out where the model is failing and how to fix it. And I will say, detailed error analysis is often missing in NLP system papers, which is, when I review, something I bring up.
So I think it's also safe to argue that it's also hard, like, how do you come up with like a meaningful statistic that's inherently a hard problem, because it's very often, if the entire entropy of the entire world and you're basically doing this massive dimensionality reduction to a single number that tells you how good you're doing, obviously you're losing a lot of information there most of the time, but it's easy to quantify. That's the main reason why people like it, I guess.
Yeah, hard to do gradient descent on, like, did you make the world a better place?
Yes.
Even though that might be the thing that you actually want to measure.
Yeah,
and Amir says, when we were talking about behavioral testing, I like to think of behavioral testing as a black box testing where you don't know how the internal model / code work, and you just care about how certain types of inputs affect the model's output. So you're testing the behavior of the model. This isn't like an ecological testing in situ.
It's hard to find. Those words are actually quite specifically explaining that, but at the same time, you can still interpret it another way. Thanks for the clarification, YouTube.
Yeah, thank you. Hello, Rasa and Robin. Welcome to the stream. Do you want to take the next section while I drink some coffee?
Please do. A number of additional evaluation approaches have been proposed, such as evaluating robustness to noise, which I'm not familiar with, or adversarial changes, fairness, logical consistency, explanations, diagnostic data sets, and interactive error analysis. I don't know if we have to go through all of them, but the main point that they're making here is that this is an active area. People are looking for interesting ways to properly evaluate these models. However,
we can talk about them quickly if you're interested.
Sure, I'm just not aware of all of them. So I imagine robustness to noise is like add one random word to a sentence, and is the classifier still able to do the right thing? I can imagine that's robustness to noise.
Yeah, it's like perturbing the input data set, which, I mean, when people talk about noise in NLP, they're often talking about typos or
out of vocabulary words, those kind of things.
Yeah,
that makes sense.
So noisy text is text that has like the text that you would chat with your friends in a very informal setting where you're not writing carefully, and this is compared to a lot of the training data, which is very formal.
Yeah.
Adversarial changes, so this is like a security thing if someone's trying to break your system. So you might have seen some examples of this from computer vision, where a couple of, there's a mask placed on an image that is not visible to a human, but will completely change the classification of the system. So similar in text, Fairness, many definitions of that. We've talked about that quite a bit. How does it work for different subgroups? Logical consistency, I think, is hopefully kind of easy to understand. Like, is there logical consistency in the things? And this, I'm imagining, is the same author. Explanations is clicked. Can you explain why you have the specific judgment that you have?
Yeah.
Diagnostic data sets. I think these are task-specific data sets.
Yeah.
Interactive analysis.
I can imagine if you have like a very general model, it's supposed to do like a general task, that you might then also get like really specific data sets to see how well they score on those, to maybe infer something. And interactive and error analysis, I imagine, are a little bit more in the dashboard area where you can sort of interact to gain an understanding of them.
Sort of similar to what you can do with What Lies if you were using that for an error perspective. Checking with the chat. Geeky Girl Sarah says hi. Hi. Shashant says, hey, Robin's gonna get a Rasa t-shirt. Yay.
Hey.
Oh, from Rasa X. Oh, are you a power user? Oh.
Fancy.
I don't know that we've talked about that publicly, but if you're really into Rasa X, there may be a little secret hidden surprise for you.
This paper reading session is turning into an announcement for future announcements.
Anyway. We get back on talk.
Yeah.
Sorry.
Okay,
so many different ways of evaluating models.
All of which I will say, all of which have something reasonable behind them as well. That said, however, these approaches focus either on individual tasks, such as question answering or natural language inference, or on a few capabilities, like robustness, and thus do not provide comprehensive guidance on how to evaluate models. Software engineering research, on the other hand, has proposed a variety of paradigms and tools for testing complex software systems. In particular, behavioral testing, which is now going to get defined, also known as black box testing, is concerned with testing different capabilities of a system by validating the input-output behavior without any knowledge of the internal structure. While there are clear similarities, many insights from software engineering are yet to be applied to NLP models.
Yeah, that's definitely true.
Yeah, and well, one thing that's someone actually pointed that out to me, that this whole software engineering, there's also a small academic field where they actively do this sort of research. Just for mentioning it to people who find that interesting, there are really cool data sets that you can play with, where people are doing also like, hey, what is the effect of sleep on unit tests that are passing? How well do engineers perform if half of the unit tests are not known to them up front, that they have to pass? There's actually quite a lot of, I would argue, relevant and interesting research happening in that field. But what they're aiming here is they're saying, well, from that field, there are some lessons that we can do more of in NLP.
And I think the sort of disciplinary lack of focus on testing in NLP is really more for historical reasons, because as a field, it's kind of only relatively recently that NLP systems move very quickly from research into production. And the idea of an NLP engineer is a little bit newer, and for a long time it was a fairly, either the systems were simple enough that you could basically build them from scratch if you needed them inside an existing thing, like a lot of the Markov chain stuff, or they were not like ready for prime time. So for a long time, like really weird, interesting NLP systems were very much designed by and for researchers. And the thing about a research project is you need it to work as long as you do until the research is done, right? Until you publish the paper and you're like, we tried it and we worked. And it is rare in NLP that a research problem continues to work on long term and the same system is kept up and running. I'm trying to think of examples, and like WALS maybe, which is a linguistic atlas that talks about different linguistic features in different languages around the world, and that's not quite an NLP project. So
I think a part of this is also like it's pretty easy to pip install Spacey nowadays. Like if you want to compare what it's like to do applied NLP in a business setting, the fact that pip works the way it does, I mean, it's I wouldn't say it's commodity, right? But it's like so much easier to get started with. Just fiddle around and put something live out there. So I think because that's become more of a practice, there's also more of a need to think about this discipline and sort of, okay, how can we actually add properties that are constraining the bad stuff and only letting the good stuff happen? Contributing theory, at least.
Yeah, definitely. So it is really nice to see testing and engineering best practices get favorable attention from the research community. You had this one. This one can be me.
Yep.
In this work, we propose Checklist, GitHub link, a new evaluation model and accompanying tool for comprehensive behavioral testing of NLP models. Checklist guides users in what to test by providing a list of linguistic capabilities which are applicable to most tasks. To break down potential capability failures in specific behaviors, Checklist introduces different test types, such as production invariance in the presence of certain perturbations. So this is robustness, being able to handle noise, or performance on a set of sanity checks. Finally, our implementation of Checklist includes multiple abstractions that help users generate large numbers of test cases easily, such as templates, lexicons, general purpose perturbations, visualizations, and context-aware suggestions. And I'm assuming we're going to talk about all of these in more depth later on, so it's not worth talking about each of them now.
But what is suggested, though, is that what we're not doing is necessarily introducing a super new test. It's what it's more alluding to, at least. It seems that we're making a tool where all of this stuff just becomes a lot easier, and you need one tool to do that in. But that's what I am hearing, at least.
Yeah, I think that makes sense. And I think it's
and there's a GitHub project, so that makes sense. It's a tool.
I think it's no surprise that people are more likely to use things that are easier to use. So yes. It sounds like it could be a really helpful contribution. And I think, perhaps obviously, I think Vincent and I, as we're reading this, will be thinking about conversational AI and dialogue systems. And is this going to work well, in our work?
In our field. Yeah. But it is always nice to see a GitHub attached to a paper. I mean, these you can explore. You want to take this one?
Can we take the next paragraph? Oh, I can take it. And then we'll look at the example here.
It feels like there's a big figure coming out.
As an example, we checklist, verbing, a commercial sentiment analysis model in figure 1. So sentiment analysis is like, is this text positive or negative? Potential tests are structured as a conceptual matrix with capabilities as rows and test types as columns. As a test of the model's negation capability, we use a minimum functionality test, i.e. a simple test designed to target a specific behavior. This must be a term from testing. This isn't a linguistic test.
Okay.
It is a test of linguistic capabilities, but this is not a test that comes from linguistics. We generate a large number of simple examples filling in the template, negation, positive positional verb? I don't know what the POS here means.
Part of speech, I think.
Well, but these are...
Or positive, yeah, okay. Positive, part of speech verb, but a verb is a part of speech, so probably positive verb then. So I like the thing, I enjoy the thing. Probably...
Maybe they're just using a weird tag set.
Yeah.
Because it has to be a... if it takes... a subject, it has to be a
special
transitive verb. Wow. So maybe it means transitive verb.
One POS is kind of an odd abbreviation for it, but
actually, I'm just going to quickly look up the PenBank tag set. PenBank POS verb. PenBank is the Penn Tree Bank.
That's from the Penn University, right? Are you saying that correctly?
Tag. I'm just pop this up. Yeah, no, it's definitely not. So here, POS would be possessive ending.
Yeah.
All right, they just came up with a tag from, or maybe you're using it from a system I don't know.
It might be explained later. We'll see.
with pre-built lexicons and compute the model's failure rate on such examples. So you have a lexicon of negations, a lexicon of POS verbs, and a lexicon of things, and you just sort of like mix and match.
Yeah.
Named entity recognition is another capability tested in Figure 1b with an invariance test, perturbations that should not change the output of the model. In this case, changing location names should not change sentiment. So I love Richmond should have the same sentiment as I love Burbank. In Figure 1C, those are both places in the United States. In Figure 1C, we test the model's vocabulary with a directional expectation test, perturbations to the input with known expected results, adding negative phrases and checking that sentiment does not become more positive. As these examples indicate, the matrix works as a guide, prompting users to test each capability with different types of tests.
For the,
okay.
For the latter one, okay, let's first do all the figures actually. But for the latter one, I think I can come up with a counterexample, but we'll see. Let's first do the figures because this is a lot to take in.
And the specific type of tests that we're expecting to see is, does it do the specific behavior that we want it to do? In this case, can it handle negation? If we change things that should not change the output, does the output in fact not change? And if we change things, this should also be italicized for parallelism. If we change things with an expected result, we expect our output to also change. So it doesn't matter what the sentiment analysis system is doing, it matters what the input and the outputs are. All right,
okay.
To the figure. Zoom in a little bit. Okay, so here are the capabilities. So vocabulary, I forget the specific thing that vocabulary was doing.
Could you zoom out just a little bit because it might be in the figure? Yes.
Checklisting as commercial sentiment analysis model G. Tests are structured as a conceptual matrix with capabilities as rows and test types as columns. Example of each type. So negation. Oh, I see. So they test negation with this minimal functional test. They test named entity recognition with the invariance test and vocabulary with the dir test. So they're not doing all of the combinations here.
Right, okay. Oh, so there's different, okay, so there's a different task and there's a different test, and this is sort of a matrix for all the different tasks and tests, and we see that not all of them are filled in, but we see that where there's an A, we do see a test case, and we can have A example. So we have specific tests, and for those specific tests, we have summary statistics. Okay.
Hi, Siddhartha. And Faisa says, live coding for sending email. I replied to your comment. I don't know if you saw it earlier. Probably not for the next little bit. Okay, so this first test A is a minimal functional test for negation. And they are saying, I can't say I recommend the food. So can't say I is negation from their negotiating vocabulary. Recommend is this verb. Positive?
Yeah.
Oh, I think it is positive because this is sentiment analysis, right? And recommend and love are both like, these are things that should have positive sentiment. Okay. And then thing, food, and flight. And
okay.
They didn't pass. So both of these should get a negative rating. This one got a positive rating, and this one got a neutral rating from the system.
Okay. So let's just to come up with attempt to come up with a counterexample. So suppose you said I didn't mind. But mind is not necessarily a negative verb. Yeah. That's the thing. Okay. All right. Okay. It doesn't cover all the ground, but it's a sensible test. All right.
Mm-hmm. And there were, I think, way more examples. This ... is sort of hiding. And so this system got 76% accuracy on this. So 1/4 of the time, if you negated the positive verb, the system didn't pick up on it. And then this named entity recognition test, they changed Chicago to Dallas and Brazil to Turkey. And the expectation is that the sentiment shouldn't change, but going from Chicago to Dallas took it from positive to neutral, and going from Brazil to Turkey took it from neutral to negative. So these this is failure rate. So 3/4 of the time negation flipped out the system, and 1/5 of the time changing the entity changed the sentiment evaluation.
Okay, that explains why it's in red. One thing I do want to mention about that test B, I find that really sensible. I mean, what you can imagine is that maybe on certain parts of the flight, people are complaining more for whatever reason. However, a sentiment model should not use that as bias. So, for example, suppose that there are more complaints about flying to New York, maybe because more people fly to New York and more things could go wrong because of it. It's not the case that then the model should learn that New York is a negative term. That would be wrong. So in that sense, I find this a sensible test, actually. I can also imagine that you're testing something that could go wrong.
Yeah, definitely.
Fair enough.
And there is a lot of... Did we read this paper? Anyway, there's been a lot of work done on bias in NLP models that are trained from things like review data sets that have found that said, Mexican restaurants get worse reviews in general. So like Mexican, as in Mexican food, is oftentimes identified as a negative term due to, factors that have nothing to do with the inherent semantics of Mexico.
That's wrong on two levels. One, Mexican food is amazing.
I mean, no argument here.
Like, if there's any American food that I miss here in Europe, it's Mexican food. Just want to have said that. But I can totally see that this happens a lot in lots of different places, and this is a nice example of bias. So I can definitely imagine that you can construct something like that using something like a domain-specific language, where maybe it's a type of food, indeed, like your example, as opposed to just a city. So this is just a sensible test. Just wanted to point that out.
Definitely. And if your model is changing things, then it's probably picking up on noise or has some inherent biases in the model that you probably want to remove. And then the final one, which it did worse on than this named entity recognition, but better than the negation, testing vocabulary, sentiment monotonic decreasing. So by adding these sentences, we would expect the sentiment to go down. Although I would say lame is not a term I would recommend using. It is derogatory towards disabled folks.
Well, I mean, in general, I recommend people just not be mean on the internet. I dread you is also something I recommend you not say to just anyone. For a lot of reasons.
But if you did say it to someone, you would expect that to reduce the, emotional polarity of.
Yeah. Okay, that's fair. Like, let me put this. If I were a comedian and you wanted to use a term, then I dread you was probably better for a laugh for a couple of reasons. In that sense, that's a cool to point out. But again, here the test is if you were to add the sentence "I don't like this" to another sentence, I mean, maybe the sentiment stays the same, but it should never go up. That's the main thing that they're testing here.
Yes.
And monotonicity. Cat wants to come in, but monotonicity in general is a good property to have, and if you have it, feel free to test it. That's sensible.
So can you show us your cat? If it's amenable.
You can kind of see her
there. Yeah. It's white on white on the windowsill.
Yeah.
Thank you.
Got two lovely cats. We have the black floof, and that's the white floof. Anyway. But in general, one thing I do want to mention about monotonic models, they do exist, and they tend to be great because you can interpret them very well. And especially with things like sentiment, it definitely makes sense to check these sorts of things. That's nice.
And it's been a while, but as I remember, a monotonic model is one which is always decreasing or always increasing, so it's easy to.
It's
Or
also
is it
it's also allowed to stay flat.
parabolic?
So you're also allowed to stay flat. That's the idea. Another nice example of this might be if we think about the amount of money that you're supposed to get from your healthcare provider. If you're less healthy, you should get more money. You should never get less money, for example. It's also one of these rules. If you smoke more, you should be less healthy. And any machine learning model that does not pick up this pattern, you could sometimes argue, is wrong. So this is certain models have this property that they're monotonic, and it's a lovely constraint.
Mm-hmm.
It's a guarantee in production, which is nice. In this case, the model doesn't necessarily have that guarantee, I think, but they're just testing the property, which is also fair.
And I will say something that pops out to me at this, and that might just be because I have spent a lot of time speaking English, is I dread you is kind of a weird thing to say. I don't think I've ever heard anybody say it before. I hate you is, I'm not saying that to anyone in this call, but I hate you is a very common thing to say. And dread and hate are synonyms. So this looks to me like there is a template and they are replacing synonyms. And I'm sure they're going to talk about this in more detail, but that does seem like something that could lead to very odd, unnatural test cases. And it's very possible that I dread you is very common in a variety of language I'm not super familiar with, but to me that sounds like very stilted.
I think it's fair to mention that it is an artificial example for sure. I think I have a similar feeling. Like I think like Old English people might say I dread the day, but then you have to like read Shakespeare or something. It's not something that people would post on social media today or something like that. But then again,
and I was like, Shakespeare, this is just like linguistic tangent, is early modern English. Old English would be like Beowulf.
Definitely not my field, just want to also make that clear. I will say like some unit tests can also be artificial, right? Like you're testing edge cases. So in that sense, I can live with the fact that if it's an artificial test case, because it's supposed to still be a test case. But it's definitely fair to point out that we should have more than just artificial examples, though. That will be suspicious.
Yeah.
Are we
Robbie
gonna...
says, nice discussion, Rachel and Vincent. Even the teddy bear listens very camp-frilly. I think Robbie's referring to your
teddy
your
bear.
husky back there.
That's my roommate in my office. That's a husky I've had since I was 16. It's also the arch nemesis of my cat. My cat is not really in favor of that thing, but thanks. It's I agree. It's a lovely prop. Do we want to check? Oh yeah.
Take it back to the paper. The husky is the mascot of the University of Washington, which is where some of these authors are from.
Well done. Huskies are fun. Do we want to check the other figures first before we continue on reading? Because this was just figure 1, right? Or is this? Oh, it's figure 1, B, and C. Right.
Yeah.
Okay.
Yeah, it's the only one we've reached in the text so far.
Okay, I just wanted to check. But okay, so far I would argue reasonable test cases.
Yeah, no, I think this looks like also fairly good coverage. It's kind of rare for people to test negation, and as you can see, this model cannot handle it. So I think adding that to a test suite is extremely reasonable.
Also, negation is not a solved problem.
No.
To be fair to say that. Is it your turn or my turn?
I think it's yours.
Okay, sure. We demonstrate the usefulness and generality of checklist via an instantiation on 3 NLP tasks: sentiment analysis, sentiment, duplicate question detection, and machine comprehension. While traditional benchmarks indicate that models on these tasks are as accurate as humans, checklist reveals a variety of severe bugs where commercial and research models do not effectively handle basic linguistic phenomena, such as, and there's a list, negation, named entities, co-references, semantic role, labeling, etc., as they pertain to each task, and that part is emphasized. Just to double check, if so negation we've discussed, named entities is detecting, let's say, a person in a sentence. Co-reference, is that where My brother was drinking a beer. He liked it. That then he refers to my brother. That's co-reference.
Yeah, pronoun resolution and like mapping what refers to is definitely I think
Okay.
the most common way of doing that.
Also no, not an easy problem. And then semantic role labeling. That one I'm unfamiliar with. Do you know what that is?
Yeah, I'm gonna double check because I think that semantic roles have slightly different meanings in linguistic and NLP. I would think that semantic role would be like agent, patient, object. So within a sentence, identifying which entity has what relations to other entities in the sentence. And I'm just double checking that that is in fact what it is.
We are literally checking semantics now.
Yes. Yeah, agent theme. Okay, yes. So there's a variety of labels. So the agent is the thing that is doing the action in the sentence. Instrument is a thing that is used to do the action. So
But it's not the same as dependency parsing, is it?
No.
No, exactly.
No.
Okay.
It's you don't have to. You can label the semantic role of one thing in a sentence without labeling the semantic role of other things in the sentence. For dependency parsing,
right.
you have to have the relationship between everything between the sentence.
Yeah, so the dependency part, you kind of have the tree of the entire sentence, whereas here it can be a sub-sentence, but you still need to know certain relationships between certain tokens of the utterance.
You know, a little detail.
Yeah, that's well,
hi.
she doesn't like being picked up, but she is cute and she's hanging around, so you're gonna see a tail once in a while. You might hear her purr in the mic. Anyway.
Yeah, so those are those tasks, and I'm sure we'll talk about them in more detail.
Okay, but it says etc. So this is just a subset of the tasks. I think they want to do something general here, but the main point they want to make is that they still find severe bugs as they pertain to each task. So they find task-specific bugs, which okay, that's not bad to emphasize.
Not at all.
Further, checklist is easy to use and provides immediate value. In a user study, the team responsible for a commercial sentiment analysis model discovered many new and actionable bugs in their model, even though it had been extensively tested and used by customers. In an additional user study, we found that NLP practitioners with checklists generated more than twice as many tests, each test containing an order of magnitude more examples, and uncovered more than 3 times as many bugs compared to the users without checklists. I believe this was also in the abstract.
Yeah.
Okay. So we get a bit of so what have we done in part 1? Well, we've gotten a bit of a preview on what this checklist thing is. We're now going to go in depth more on what it is, but to get a bit of a flavor, it seems to be a tool that makes it generates a bunch of relevant test cases for specific NLP problems.
Robbie says, Vincent, your cat is very cute. What's her name?
Noah.
Noah.
We have 2 cats. One called Noah. When we got her from eBay actually. Like her owner was moving to a place with a big dog, so someone else to take care of it. So we took care of her. So this cat was already named. Our other cat is called Sock. It's because she has little white mittens that look like she's wearing socks all the time.
Very cute.
Yes, darling creature.
Anyway. Checklist. Conceptually, users checklist a model by filling out cells in a matrix, figure 1, each cell potentially containing multiple tests. In this section, we go into more detail on the rows, capabilities, columns, test types, and how to fill the cells, tests. And based on the last paragraph, the way that you fill the cell will depend on your specific model. Checklist applies to the behavioral testing principle of decoupling testing from implementation by treating the model as a black box, which allows for comparison of different models trained on different data, or third-party models where access to training data or model structure is not guaranteed. So it looks like
granted. So the last word wasn't guaranteed, it's granted.
Oh, granted. Sorry, thank you. So it sounds like another helpful use of this particular approach would be to for a team that's evaluating maybe different models and trying to figure out what product they want to use for a specific project, to compare them on these various qualities, metrics, as opposed to the single metric of accuracy or whatever it is that you're looking at.
It starts sounding kind of like the hypothesis tool in Python. It's just a tool that makes it easier to write more sensible unit tests for a specific task that you have in mind. Fine-tuned to NLP in this case, but so far so good.
Do you want to take on the next section?
Sure thing. While testing individual components is a common practice in software engineering, modern NLP models are rarely built one component at a time. Instead, Checklist encourages users to consider how different natural language capabilities are manifested on the task at hand, and how to create tests to evaluate the model on these capabilities. There's a distinction between the task and the capability of a model.
Yeah.
Interesting to see where that's going to go. For example, the vocabulary plus, I suppose here it's part of speech capability, pertains to whether a model has the necessary vocabulary and whether it can handle impact of words with different parts of speech on the task. For sentiment, we may want to check if a model is able to identify words that carry positive, negative, or neutral sentiment by verifying how it behaves on examples like "this was a good flight." That's a link?
Nope, it's just blue.
For QQP, which was an abbreviation we saw earlier, which is question answering?
Duplicate question detecting, I think.
Duplicate
so that would be like...
is it cold tomorrow, or is it going to be not warm tomorrow? Would that be a duplicate?
Yeah. Or even like, what will the weather be, or what will the temperature be tomorrow?
Right. Yeah. So instances where you're essentially asking the same thing. I'm not going to make another FAQ bullet in my FAQ list because of this.
And this might be, I think, of these tasks, the most relevant to us in particular, because duplicate questions might be the same intent.
Yep. Yeah. Pretty much. Or if you just look at, if you have all sorts of questions that users ask to you on Twitter, it'd be nice if you can automatically generate a frequently asked questions list from it, for example. I can also imagine that's a relative common use case for this. Anyway, for that use case, we might want to model the model to understand when modifiers differentiate questions. For example, accredited in, is John a teacher? Or is John a accredited teacher? So
it could. Yeah. I was just gonna say it could be true that John is a teacher, but that he is not accredited. So accreditation, at least in the US, is very expensive to maintain. You usually have to like take multiple courses a year to maintain your accreditation. So sometimes it can lapse.
And depending on, and it depends on the context whether or not those two questions are the same.
Mm-hmm.
But welcome to the problem that makes the problem hard. For MC,
which was machine comprehension.
Right. For machine comprehension, the model should be able to relate comparatives and superlatives. So context: Mary is smarter than John. Question: who's the smartest kid? And an A would be Mary. Okay, so I get what the
comparatives are like more tall or taller, and superlatives are like the most, so tallest.
So, but I get what the point of this paragraph. See, okay, I get what the point of the paragraph is as well. So there's different tasks, and let's say for this task we have 2 or 3 tests, sort of, or like qualities or behaviors that we expect. Mm-hmm. So that's nice because that might mean you get to reuse tests across tasks, which is good. It's the main thing I'm getting out of this. And you want to take the next one?
Sure. We suggest that users consider at least the following capabilities: vocabulary and part of speech, important words or word types for the task, taxonomy, synonyms, antonyms, and etc. So like the semantic relationship of words to each other. Robustness to typos, irrelevant changes, etc. So when we talked about adding noise or perturbations or Code switching, I guess, could be a type of noise where people will use multiple languages in the same sentence. Can your model handle that? Named entity recognition, appropriately understanding named entities. This one is really relevant to dialogue systems. Fairness, depending on what specific measure you're using. Equivalent behavior across subgroups is one that I tend to use a lot. Temporal, understanding the order of events. So if you have for a dialogue agent, you might say, set an alarm called feed the cat for 5 minutes, and then 5 minutes after that, set another alarm called check on the cat. I don't know. Give the cat water. Something else.
Pet the cat, but
yeah, exactly. But you don't want to pet the cat while it's eating. You gotta give them their food bubble.
That's a really good example. You totally don't want to do that.
Negation, so X, not X. Code reference, pronouns, pronoun resolution. Semantic role labeling, understanding roles such as agent, object, etc. And logic, ability to handle symmetry, consistency, and conjunctions. So this is like logic in the sense of formal logic.
Okay, but and these are capabilities which to some extent can be tested, and what they're arguing here is that users consider for their use case whether or not there's valid tests with that theme in mind.
Yeah. And then what specific tests you use for each of these use cases will depend on your specific application.
Yeah, that's okay, so far so good.
We will provide examples of how these capabilities can be tested in section 3, tables 1 and 2 and 3. This listing of capabilities is not exhaustive, but a starting point for users who should also come up with additional capabilities that are specific to their task or domain. So things that would work, like if we were going to add something for dialogue systems here. I don't know if you can hear that.
A little bit.
There's a brass band playing outside.
You can hear a little bit of it, but only if you pay attention to it. It's not bothering me.
Very weird.
Okay, so digital assistant use case, named entity recognition is a use case for sure.
And I think they're suggesting that you do tests for all of these for all NLP systems. I'm trying to think if there's anything in particular that I would want to add.
So for us, one of the core things that we got to do is whenever a user asks, hey, are you a human being? Then we should always say no. So that's
when a user asks a system.
Well, yeah. So like we should never pretend to be a human. It's like a kind of it's kind of a core thing. Like if you don't do that, then you're risking being unethical. So I'm wondering if that's maybe an extra, but I guess you could say that's maybe logic.
Yeah, I think
this covers a lot of ground.
Also, go ahead.
No,
it does. It covers a lot of ground.
Yeah.
And also, these would be in addition to other tasks. So, like identifying that someone is asking if you're human or not. Like, I think you could do that using sort of our accuracy measures for intent classification.
Yeah, but it's not a guarantee. That's the thing. So the Rasa's going to have a rule policy soon, and this is one of the features I'm excited for this feature for this reason. Yeah. I guess one thing you could also maybe add is like it's a different realm, I suppose, but like something about how long it takes to respond. Like that's not mentioned here because that's typically done by typical software engineering techniques that are quite well known. So I can imagine.
I don't know that that's also a linguistic test.
It's not.
I don't know. So. We haven't finished the paper.
Yeah, but so far these are reasonable things to pay attention to. Definitely. But my impression is like I've not seen all the test cases that it could maybe help out with. I've also not seen how it exactly works. Like I might be curious just to have a quick look at the code base because, but yeah, but so far like only reasonable things have been mentioned, I would say.
Huh. Do you wanna
Sure.
So I know you have a thing after this. Do you want to take this next section and let's see if we can get to, I don't think we can get all the way to 3. Maybe through this test types?
Sure, well, we'll see. The main thing is, like, when the food arrives, I gotta open the door and then it's food time. That's the deal I made with my soon-to-be wife. So that's
Very reasonable.
the deal I want to adhere to. But okay, let's go. We prompt users to evaluate each capability with 3 different test types when possible. Minimum functionality tests, invariance, and directional expectation tests, the columns in the matrix. A minimum functionality test, inspired by unit tests in software engineering, is a collection of simple examples and labels to check a behavior within a capability. I prefer to refer to them as minimum functionality tests as opposed to abbreviation, but a minimum functionality test is similar to creating small and focused testing data sets and are particularly useful for detecting when a model uses shortcuts to handle complex inputs without actually mastering the capability. The vocabulary plus POS examples in the previous section are all MFTs.
And for transformer-based models in particular, we know that this is a big problem. That models, instead of modeling the relationship between terms, will pick up on the presence of a specific term. So the was it Kevin and Cow maybe paper, Nevin and Cow, on BERT looking at negation, and found that what BERT was looking for was not sort of like what was negated, but the presence of the word not.
Okay. So it's not necessarily that it's memorizing this. It's just it's learned a pattern that's not exactly what we're going for.
Yeah, exactly. And they're suggesting that this particular test should help to identify that for all of these things that they suggest that you consider.
I wonder if this is so far this sounds reasonable, but I'm wondering what this tool is going to automate, because it sounds like you're writing PyTest tests so far, but we'll see. So I'll take the next one as well.
Really quickly, there's a question from the chat. Arnav says, any pointers on measuring fairness? Wouldn't selective checking across a few categories be problematic as well? It really depends. So for NLP systems, we know that, I mean, the biggest thing about fairness is like, should you be building this system in the first place? And the Dion checklist that Vincent was mentioning before has an ethics checklist. For modeling, I think would be the most.
There's also data quality
section.
issues. Like, there's also data quality issues, which are like, I would just take all of them serious. If you're a data scientist,
Absolutely.
I wouldn't just focus in on the modeling bit, because if the data is going into your model, what's going out of your model, if that's your responsibility, then the stuff going in is also part of it. But the main thing with bias, it's just an incredibly hard problem. One that I have issues with sort of pretending, like, I don't want to guarantee that it's solved. And if you guarantee, like, I do agree that, we've solved the fairness problem on one axis on how we can measure it. Okay, if you're saying let's be careful with that, it's limiting because you're only focusing on a certain aspect. I would say, okay, that's good to point out. But it's better to assume that all models are unfair. Like, that's a safer sort of vantage point to start designing from. And then to wonder, hey, how can we constrain the unfairness? That's probably a better idea than to think that you can remove the unfairness. That's I've been studying this thing for like a year and a half, and I'm growing increasingly skeptical of the entire endeavor. It's still noble. Definitely people should research it, but it's hard.
It's very hard. And I would say that if you are talking about fairness and communicating that to stakeholders for your models, it's important to include a number of metrics to give them a good understanding of sort of the range of behaviors that your model is modeling. And the other thing is the groups that you are considering and are paying specific attention to are going to be very dependent on your both your application and also the larger social situation into which the application will be deployed. So just as an example, in the US, there's not like a special discrimination against people with albinism, but in, for example, South Africa, that's a big problem. So I probably wouldn't include a fairness test for specifically people with albinism in the US, but if I had a system that was going to be deployed in South Africa, I definitely would. So it definitely requires an understanding of the social context into which the model will be deployed. You can't get out of sociology.
Oh, and one final comment. If you're actually interested in sort of fairness and getting to the nitty-gritty details, I'm actually making videos right now on the algorithm whiteboard on the very topic. The video that I just released last Monday demonstrates that it's really easy to fool people with fairness statistics and that you should be really, really careful.
Definitely. So to answer your question, Arnav, it's hard. I would include more tests rather than fewer tests. We did this section.
Yes, and I was going to continue from there. Yes.
Yeah, go ahead.
So we also introduced 2 additional test types inspired by the software metamorphic tests. A invariance test is when we apply label-preserving perturbations to inputs and expect the model prediction to remain the same. Different perturbation functions are needed for different capabilities, like changing location names for the named entity capability or sentiment. Hang on. So different perturbation functions are needed for different capabilities. So, all right. So you need to be able to do named entity recognition in order to do perturbations for sentiment?
So I think what they're saying here is that you need to pick a perturbation that shouldn't affect the thing that you're testing. So if you're testing named entity recognition, changing the named entity is probably more likely to affect the output.
Yeah.
You're trying to change things that shouldn't affect the output.
Oh, the doorbell is ringing, so I'm quickly gonna have to check whether or not that's the food. Sorry.
Yeah, no worries. I can take the next couple.
I'll be back in a jiff.
Thanks. Sure. All right, I'll continue. Or introducing typos to test the robustness capability. So this section is talking about different ways that you can change the input that shouldn't change the model output. A directional expectation test, DIR, is similar, except that the label is expected to change in a certain way. For example, we expect that sentiment will not become more positive if we add "you are lame." Again, kind of discriminatory language, wouldn't recommend using that. To the end of tweets directed at an airline. Figure 1C. All right, was that the food?
Sorry about that. That was non-food related package delivery.
Okay. So we talked really quickly about the directional expectation test. So the invariance test, we expect no change for the specific input change. Directional expectation test, we expect a specific change for our input change. I can actually keep going because
sure, go ahead.
Took over the program. Daniel 10 says, yes, the work from home, why did my doorbell ring problem.
During a call, yeah.
Yes, I mean, we spend a lot of time in call these days.
That's true.
The expectation may also be a target label, e.g. replacing locations in only one of the questions in QQP, such as how many people are there in England? What is the population of Turkey? So by changing one of the named entities, we expect the judgment, these are the same question, to change to these are different questions because they're about different entities. Ensures that the questions are not duplicates. Invariance tests and directional expectation tests allow us to test models on unlabeled data. They test behaviors that do not rely on ground truth labels, but rather on relationships between predictions after perturbations are applied, invariance, monotonicity, etc. Unlabeled data is very important because labeling data is expensive. It's expensive in time, it's expensive in quality control.
And still hard to get right.
Yes.
Okay, but so what I'm now assuming is that they might also have some helpers to help with these tasks, like, hey, how do you perturbation? If you know, there's an identity recognition thing here.
Yeah.
I'm assuming that's some sort of toolkit that offers that kind of things.
Yeah, it sounds like they're going to do some sort of like templatic paraphrasing for us, is my expectation, based on sort of what they've said so far, and also, as I mentioned, this example, which just ooh, that's a templatic paraphrase.
That one is.
You just searched to replace some synonyms.
You really dread that example, don't you?
Like, it's not wrong. It's not ungrammatical. It does sound like something like the heroine in a gothic novel would say.
Yeah, it's again, that's why I made the reference to Shakespeare. It's something that you wouldn't write right now. It's something that's from a past age, so to say. Just like, how old art thou? You wouldn't say that. I would understand what you're saying, but I wouldn't use the word thou. I think.
Yeah, no, English pretty much completely lost its informal second person.
Oh, that was the informal one.
Yes, that was the informal one.
Oh.
And the reason it's used a lot in sort of biblical context is just like in French, you use the informal when talking to God.
Oh, okay. I learned something today.
Do we want to wrap it up here? Because we're right at a section ending, and we've been here for a little bit over an hour.
We could. I mean, I still have some time. One thing, if we have a little bit of time, like say 5 minutes, could we just have a glance at the repository?
Yeah, for sure.
Because I'm just interested. I'm just a little bit curious now. Like, okay, like I get the impression that's trying to do. Is there maybe also like maybe a getting started thing?
I'm gonna start this.
This is pip installable.
Okay,
paper.
Reference to the paper. Checklist, table of context. Okay, so here is, let me zoom out a little bit so we can see all of this. Pip install checklist, so it's on IPI.
Yeah. And there's a notebook extension, yeah.
Which is really nice. There's the sys instance in virtual environments such as Conda or virtual and okay, helpful.
You can pip install it, you can do it from source. You need to have they do some masking stuff, so then you need PyTorch or TensorFlow. So far, so good. And they use Spacey, right? I think I see where this is going to go. But using Spacey is fine, by the way. The only downside of using Spacey is great. The only downside is it doesn't necessarily support a lot of languages. They support quite a few.
Very Eurocentric, though. So if you speak a East Asian or African language, it might be a little bit harder to find the tooling.
I have found that there are efforts now to so there are tools that offer like neural network models for like very specific languages to make them Spacey compatible. That's like an effort that's happening. But yeah, very Euro focused. That's fair. So now I'm just interested in, can we maybe check one of those tutorials just real quick?
Do you have a preference?
For tubing.
All right. Oh, that's nice. It's been a while since I opened up a IPy notebook directly on GitHub. Looks like they fit the rendering thing.
Yeah, so it comes and goes. Like sometimes, like on a bad Monday, it still sort of is a little bit iffy, but it's improved immensely. That's certainly true. But apparently, you have something of an editor. You can generate some data, and then you define a function.
Yep, this is ye old search and replace.
Yeah, this is definitely templating, right?
Yep.
And then you generate,
perturb. It goes through and iterates for you. Looks like it has a data structure, which is great.
Right. So it's a little bit like the hypothesis library, but for NLP tasks. So this should make it easier for you to construct not necessarily unit tests, but test cases that you can report on.
Something to look for. It looks like it's using regular expressions pretty liberally. Yeah, I would probably just like triple check these before you add them.
There's this new package I think that tries to make like a human readable regex that might be something to look into. If you're intimidated by regex, that's totally normal. So,
very easy to make mistakes, unfortunately.
Yes. Powerful, but slightly dangerous.
All right, so lots of perturbations. They also provide some general purpose ones. So this one was for changing professions, which might be useful for your, embeddings work.
Or fanners even, to be honest.
Strip punctuation, add or remove slashes,
Well,
add typos. Oh, this is fantastic. So
Ah.
what sort of typos does it do? Looks like it does deletion.
Well, so if they're doing it the clever way, they probably do something where they look at the keyboard mapping, where if you have they don't do that, you think?
No, it looks like they're doing deletion, switching, I'm guessing, deletion, substitution, probably like doubled letters would be my
like
guess
the
based on
basics
these two
thing.
examples.
Someday I'm going to write the Python package that does this, because I've been thinking about this for a while, and the typo Markov chain seems like an interesting problem.
Yeah, definitely. Contractions, so is not to isn't, expanding contractions. So these could also be fairly useful for just general purpose data augmentation. For example, if you were generating more training data for your
True, but this is also an example that makes me think, right now they only probably support English.
Oh, yeah.
Because that perturbing is a English thing. Well, not every language does that.
No. But it looks like they do provide a lot of custom capability.
True. No, that's fair. That's definitely fair to point out.
I don't know that this is going to work super well for languages that require word segmentation, right? Because this is like a word boundary, which is really prefaced on the idea that you have white spaces between words.
With that in mind, I only want to mention that we now have more tokenizers for Rasa. Thomas made one for Thai, and I've also found one for, it's in testing phases right now, and it's for the Rasa LU examples, but we now also support a version for Hindi, one for Arabic, and a bunch of other ones. But we're actively working on better tokenizers for Rasa, because it's important we get those right.
And also, if there's a language that you're familiar with in the audience, and we don't support yet, please feel free to make a pull request. We would love to see it.
Or just reach out to me, and I'll gladly make one for you when I find the time. I would love to hear if there's missing support for languages for certain tokenizers, especially.
The percentage Python formatter for that regex. You have to ask them. Yeah, you could definitely use f strings here.
Probably. Can you do f strings in a raw string as well?
Pretty sure.
So it's because it's a raw string. There might be like a caveat there.
Can you use f strings in a raw string?
I don't think you can do like an f and an r before a string to make it a raw f string.
It's not mentioned in the documentation whether you can or not.
It might very well be the habit of the author of the notebook, and habits are really hard to unlearn. So if you've been doing Python 2.7 for over a decade, which some people have, then I'm not going to blame you that this is a habit that you're not going to unlearn in a jiffy.
Also, looks like we just disconnected, so we're waiting for the reconnection. I don't know if you can hear me. For me, because I can hear my echo, I sort of like cut in and out when we have connections. All right, well, it'll be just a second.
I will say, I suppose we just continue talking until we get the connection back?
Yeah, okay, we're back up.
Okay.
Yeah, doesn't usually take more than a minute.
I mean, looking at this though, it does seem like the kind of package where if I find an odd hour with nothing to do in a week, I might try this out. There seems to be some cute stuff in here to at least explore, and I can definitely imagine, like, there's some paraphrasing stuff in here. Paraphrasing to us is also useful. So especially if we can generate like spelling errors of utterances, right? That way generate more training data. Like, that's an experiment maybe worth doing. There's some stuff in here that seems like.
Wow. I'm also noticing some things about these person names.
They seem quite English, don't they?
They do. They seem like specifically white dude names.
I can imagine. I think this is so. They mentioned that somewhere above that some of these perturbations require spacey. So I'm assuming what this is doing is it's using the named entity thing inside a spacey to detect a person, and then uses that to perturb. Um, Valid, but one thing to keep in mind is that the spacey thing is not necessarily 100% perfect. In spacey, especially if you're trying to detect person names, capitalization can make or break things, especially if you're using the small model of spacey. Might be worth upgrading to a larger version if you're worried about that.
Helena, this says, can more than one tokenized dataset be used for dealing with blended languages where some jumps between two languages? Oh, so like a code switching example. That's actually something that I'm working on a video about right now. It depends. That's the answer.
Natural language is a hard unsolved problem. Doing two of them at the same time does not make it easier. I can imagine.
I will say the easiest way to handle language input in multiple languages is to, at least in Rasa, have multiple, either completely separate assistants or the NLU portion is handled separately for each language. And then once you have the intents, you feed everything into the same core model. So you have a more consistent user experience.
That said, I have heard stories where people like purposely keep the two separate, also because of cultural differences and intents not necessarily mapping the same way to actions across cultures. Again, unfortunately, you're gonna have to do some sociology here.
And if you are working with a population where languages are used sort of like in an intermixed way, or you're working with a pidgin, you need language data from that population to train your model. Can't really get around that, unfortunately.
Yeah.
It's hard.
It's hard. Also, like, so people don't necessarily know this, but even the Netherlands, right? You know, very small country, 16 million people. It's not a whole lot. I think we have two official languages because, and then between those two languages, we also have like 6 dialects where if you take someone who has a thick accent in any of these dialects, they can't understand each other at some point anymore. This is more of a problem in spoken text, I would say, than in written one. But this is just the Netherlands. I'm sure you have this phenomenon across countries in Europe, states in the United States, and, you know, pretty much everywhere. So keep collecting data.
Hello near this says it's from the baby names data set. These extremely narrow selection of names.
The baby, is that a Kaggle data set or?
I think it predates Kaggle. I think it's a.
Because I remember this one data set that was like.
Say IBM.
Could be. Yeah, so I remember there was this one data set about baby names that spanned like multiple decennia. You could sort of do analysis when one name became popular and then it started dropping again. And apparently there was this one period in 10 years where a lot of babies were called Mike. You can do that kind of research.
There's an Social Security Administration in the United States data set from 1880 to 2017. All the baby names used by at least 5 children of either sex, which sounds like what this might be.
Okay. I mean, I would still expect more than just Marks and Lukes, but okay.
And it looks like they also have a remove negation, which seems useful. And it looks like it's also fairly good about whether it
it's not just removing
removes.
Not.
Yeah, it's not just removing not. In this case, it's removing the
I wonder.
I don't want to give this verb a name because somebody will yell at me if I pick one name or another.
One thing I wonder, if you were to make an algorithm that removes negation, I think if you had a good vocabulary list in the English language that just has negation, you just map that. Like a Python dictionary would be a pretty good algorithm here if you just have a long list, right? Is it a hard problem to remove? Like adding negation, I think is harder than removing it. Wondering out loud.
Adding negation?
I think adding negation might be harder than removing it because you have to. Because the thing is, if you could be wrong, right? But it seems like removing negation is just detecting, hey, there's probably a subset of 2,000 most commonly used data terms, and you can map that to the non-negative one. You're gonna make it negative. Then you got verb conjugations. You got to figure out where to put the word not in the sentence.
Yeah, I would say that adding is harder. because you also have to consider like NPIs, negative polarity items. So there are things in English that you can only have if previously in the sentence something has been negated, and also that something is sort of like encompasses the thing that can be negated.
Okay, so the only thing I wanted to, so all in all, what I'm looking at here seems cool, right? This is easily, plausibly useful, right? And I like the direction where they're going. But some of these perturbations don't seem to me like solved problems in all cases. Like removing negation, adding negation, there might be an error made there, right?
Yeah. No, I definitely agree that this is not going to be flawless. It's going to work best in English. And I think the thing that they will probably argue in the paper is that because they generate so many examples, even if a couple of them are a little the overall number of examples will give you sort of a sense of the variation of the system.
Yeah, so it's still it's a shotgun approach. Not every bullet is going to be good, but you're bound to hit something, and that's what you care for. So, all right, that can be that's I suppose fair.
And even I think a test set that does have some errors in it is going to be better than just not running the test at all. Excuse me.
That is certainly accurately put.
All right, my voice is starting to get a little bit smoky. So if you're okay with that, I think we can wrap it up here.
Oh, this has been cool. I learned about a cool
we will
package.
Continue next week. Well, I'll be here next week. Whether or not Vincent is TBD.
I might have other obligations, but it's I'll definitely give the package a spin.
Really, yeah. Let me know how it works for you. So we got up to section 2.3, the generating text cases. That's where we'll pick it up.
Yep.
Thank you for joining today, everybody. Thank you for joining me, Vincent, and Noah as well.
Well, she's long gone at this stage, but.
We'll be back tomorrow morning with live coding. We're going to be working on I don't know if you can hear that, but there's like a full-on parade.
I can hear it. Yeah, I can hear it.
What are you doing outside right now? All right, I'm gonna take this as evidence that good time to wrap it up. Thanks for joining. We'll be back tomorrow with live coding, and I'll see you then. So long, y'all.
Have a good